Hi folks, this is Calc 2 Quiz 3. We're asked to integrate. We have two integrals here. They look hauntingly similar, yet the techniques are vastly different. When we first approach an integral, we try to fit it to one of the basic formulas we learned in chapters 1 through 5. And we have an exponential here. And so we think, is this an e to the u du form? So if it's an e to the u du form, we would let u be the exponent, and then is the du sitting around outside, and in fact this is. So we could actually make the formal substitution if you need to. Let u equal x squared. The du is sitting right there, 2x dx. And so really this is nothing more than an e to the u du. And this antiderivative is e to the u plus c. And so this would be e to the x squared plus c. Basic u substitution. Now, we compare this to the next example where I've just switched the place of the x squared and the 2x. Now it's x squared e to the 2x. And so if I let u be the 2x, then we have more of the x's than we need out front. Okay, so either it's one of those tenacious u substitutions or it's a different technique. And in fact, if you think to section 8.2, this is a classic integration by parts. We have a polynomial function times an exponential function. We can use integration by parts. Moreover, we could use tabular integration, or as we've talked about it in class, Zocchi's method. So I shall give credit where credit is due. Zocchi lives. And this is just a way of repeated integration by parts. So each time we make the integration by parts, we're always going to let u be the polynomial piece. So I'm going to start off with x squared here, and then take derivatives until I run out of derivatives to take. So these are all taking the derivatives. And the dv is then always going to be the exponential piece. And so I integrate here each time, and each time I integrate, I'm going to pick up a half from the 2x and the exponent. So this is integrating. And now I put them together for my final answer. The integral x squared e to the 2x dx equals, I go down and I multiply these. I take x squared times this, so it's x squared e to the 2x over 2, minus now, because remember we alternate plus 1 minus 1 plus 1, minus 2x e to the 2x over 4, which is going to be minus x e to the 2x over 2, because those 2's will cancel one of the 2 in the denominator, and then plus 2e to the 2x over 8, that's e to the 2x over 4, and don't forget your plus c. So that'll do it for quiz 3.